Ignition sequence start. All engines are running.
We have taken tremendous steps.
We choose to go to the moon before this decade is out.
We have achieved the earth-shaking, the breathtaking, the groundbreaking,
One small step for man.
and left a mark in the heavens. Our successes build one upon another and amplify what is possible.
The dawn of Orion.
It's time we take the next great leap. We're building the next chapter of American exploration, returning to the moon to stay, so we can go beyond to Mars, to expand what's possible and further our understanding. The architecture for these missions is already taking shape. We will go with new systems, bold designs, and a sustainable mission. You can hear it, taste it, touch it. We are going. We are training, testing, pressing our pioneering spirit into every component, defining our resolve with every line of code, and securing our success with every welcomed partnership. This is not hypothetical. This is not about flags and footprints. This is about sustainable science and feeding forward the advance of the human spirit. Because we are the pioneers, the star sailors, the thinkers, the visionaries, the doers. And because we stand on the shoulders of giants to go farther than humanity has ever been, we will add our names to the rolls of the greatest adventurers in history. Every day, every mission, we advance this calling. We are NASA. And after 60 years, we're just getting started.
Well, what an amazing day, and welcome to the James Webb Auditorium here at the NASA headquarters. We've got an amazing announcement today that we're very excited about, and we've got a lot of really fun things that we're going to see and do over the course of about the next hour. I want to start by saying the video you just saw is about the future of human exploration at the moon to retire risk and go on to Mars. This is part of the President's Space Policy Directive-1, where he directed me as the NASA administrator to go to the moon and to go with commercial partners, which is what we're going to announce today. We're doing something that's never been done before. When we go to the moon, we want to be one customer of many customers in a robust marketplace between the Earth and the moon. And we want multiple providers that are competing, welcome to the competition, that are competing on cost and innovation so that we as NASA can do more than we've ever been able to do before and advance the human spirit just as the video just said. I'm thrilled to be here today with the Associate Administrator of the Science Mission Directorate, Dr. Thomas Zurbuchen. And the reason that's important is this. Not only are we announcing today a number of very innovative companies that are going to go to the moon for the first time commercially. In other words, we're going to buy the service. We're not going to purchase, own, and operate the hardware. We're going to buy the service. But we're also announcing a change that I think is important for NASA. And that is, this is a response to the science community, who has for a long time decided that we needed to do science on the surface of the moon, and yet NASA for a long time has focused the moon within the Human Exploration and Operations Mission Directorate and not the Science Mission Directorate. But now we're changing that. We believe there is a lot of amazing science that we can do on the surface of the moon. In fact, science that we can't do anywhere other than the surface of the moon. So this mission, we call it the Commercial Lunar Payload Services Program, where we're going to go to the moon commercially with our partners. This is being driven from the Science Mission Directorate of NASA. So that's a big change for this agency. in this organization. And I'm thrilled to introduce to you Dr. Thomas Zurbuchen, the Associate Administrator of the Science Mission Directorate.
Thanks so much. When I was a little kid, just a few months old actually, I don't remember it like you don't remember when you were a few months old.
I do.
There were humans. He's the smart one. There were humans on the surface of the moon, and with them, right after they landed and put up the US flag, we're so proud of when we have pictures here, they put up a science experiment. Aluminum foil, a very simple experiment. And that foil collected material from the sun. Material we can't get here because the magnetic field in the atmosphere is in the way. And that material was brought back to Earth. And it provided the best measurements of the sun that we've had for 25 years. Only a decade or so ago, an instrument that I was part of building exceeded the accuracy of that measurement. What that tells us is just what you said earlier, Administrator, is science and human exploration go together. And we should not be surprised that I'm standing here as a scientist really excited about exploring this celestial body right next door to us. The moon, like any other body in the solar system, including Mars. God, we're still on that Mars high, you know, with that lander.
I don't know if you guys saw on Monday we landed on Mars.
Yeah, right. So the moon is full of secrets that we don't know yet. For example, if you really want to decide what the age is of the solar system, just like you look at the rings of a tree when you cut it, if you want to learn that, you go to the moon and you analyze the samples that are there. There are parts of the moon, especially when the sun and the earth are on the same side of the moon, that dark side on the other side there. It's so quiet there that we can see all the way back to the dawn of the universe in a way that we can't do anywhere else, not even on satellites. So we want to go do these measurements there. And the third piece is really exciting, and it feeds back into the human exploration side. On the moon, there's water. On the moon, there are resources, precious resources, and we want to learn how to use these resources because guess what? We want to go back with humans and actually use those resources, perhaps to bring back to Earth, or to fuel, to breathe, to drink some of these resources such as water. And we're really excited. The steps to that come from science, the very experiments that we want to fly to the surface of the moon.
Awesome. Well, thank you, Dr. Thomas Zurbuchen. We are thrilled to have your enthusiasm for these very exciting missions. In just a few moments, we're going to introduce the folks who have been awarded a contract within the Commercial Lunar Payload Services. But before we do that, I want everybody here to know that in just a few minutes, we're actually going to be going to Goddard. And we're going to hear from scientists at Goddard who operate the Lunar Reconnaissance Orbiter. And they're going to help us understand the intersection between the science of the moon and the exploration and operations on the surface of the moon. The Lunar Reconnaissance Orbiter is an amazing capability for our country and for the world to help our new, I guess, providers understand where they can land, where the best opportunities are to find those resources, the water ice on the surface of the moon. So we're going to go to Goddard. We're going to talk to some scientists about the Lunar Reconnaissance Orbiter. Then we're going to actually listen to some young folks talk to us about their own robotics capabilities. We have a number of teams here from First Robotics, and I'll just mention a few of them. The Brainstorm Troopers from Reston, Virginia are here.
All right.
The Walker Jones Tigers, there's two teams from Washington, D.C. are here.
All right.
And then we have the Cascades Thunderbolts from Sterling, Virginia here as well.
All right.
So after we talk to Goddard, we're going to actually go out to the hallway here, and we're going to actually see a demonstration of some of the First Robotics capabilities and the teams and what they've been developing. And then finally, we're going to go down to Houston, Texas at the Johnson Space Center. We're going to talk to an astronaut, and we're also going to talk to some experts on lunar materials sciences. So that'll be an exciting opportunity. Then we're going to open it up for questions, and people can ask questions online. People from the audience can ask questions, and everybody is here to really respond to the excitement that we have over our new providers for access to the moon. We have commercial companies that are going to be taking our payloads to the surface of the moon in the very near future, and we're going to introduce them right now in alphabetical order. The first one we'll start with is, drum roll. Yeah, there we go. Ask the kids, they'll deliver, right? Astrobotic Technology, represented by John Thornton.
Congrats.
Thank you.
Yeah.
We're going to have you stand right here. Wave. Yeah, you can come on across here.
Yeah.
All right. Deep Space Systems, represented by Steve Bailey.
Congrats. Yeah.
Congratulations. Ian, hold on through. Draper, represented by Jennifer Jensen.
Congrats.
Congratulations. Firefly, represented by Eric Salwan. Congratulations. Intuitive Machines, represented by Steve Altimus.
Congrats, yeah.
Thank you. Congratulations. Lockheed Martin, represented by Joe Landon.
Recognize the lander, man.
Awesome. Good work. Maston Space Systems, represented by Sean Mahoney.
Congrats, son.
Good to see you.
Yeah.
Thank you. Good work. You bet. Moon Express, represented by Devan Maharaj.
Congrats, man.
Good work. Awesome. You bet. And Orbit Beyond, represented by Jeff Patton.
Congrats.
Nice work. Awesome. So let's all get a picture here. Can we do that?
Come on in.
Yeah, there might be one.
It's a class picture.
Squeeze on through. Thomas and I will bookend you guys. How about that?
Congrats, yeah. All right. There you go.
Awesome. Thank you, guys. You might get some questions from the audience here in a few minutes, so be ready. We're ready. All right. All right. So now we're going to go live to the Goddard Space Flight Center in Greenbelt, Maryland. Barbara Cohen is standing by to tell us about our Lunar Reconnaissance Orbiter and everything they're doing there to learn more about the moon.
Hi everyone, I'm Barbara Cohen. I'm here at Goddard Space Flight Center, where we manage the Lunar Reconnaissance Orbiter for NASA. LRO is a very successful robotic mission. It's in orbit around the moon right now, and is leading the way for new human and robotic activities on the surface of the moon. There's a model behind me. You can see our great spacecraft. It's been going for 9 years. It started off with an exploration mission to map the surface of the moon for future exploration landing sites. It's gone on in its 9 years to make some amazing scientific discoveries that have created a new picture of the moon as a dynamic and exciting body that we can use to understand the origin of the Earth, the moon, and the solar system. The dual role of LRO as an exploration and science mission has proven to be incredibly successful, with important advances in both realms. LRO provides all of its data publicly, so you can go get it yourself on the planetary data system. Some of the data that we create are high-resolution images of different sites on the moon. We create maps of topography, roughness, and lighting. We create thermal condition maps, and we map resources like water ice and metals that we might be able to one day use. We're looking forward to working with NASA's new commercial lunar partners. I've met some of you in person. I'm looking forward to meeting more of you as well. We really want to help you advance lunar science and exploration and resource exploitation on the moon, and with these successful landings on the lunar surface. The LRO team is standing ready to help. We want to identify sites that are close to potential resources, things that have high scientific value. We want to make sure that the landing sites that you're able to go to are safe and have a favorable environment. We can also work with lunar landings to observe at the same time and make coordinated experiments. And one of the more interesting things LRO has been able to do is to make high resolution of images of landing sites after assets have landed. So we've imaged the Apollo sites and other robotic landings on the surface, both to see where they are and to see how they've influenced their environment. We're looking forward to doing that again with many more landings on the surface of the moon. So we can't wait to work with our new commercial partners. We want to advance our understanding of lunar science. We want to land those instruments on the moon. We want to learn more about our nearest neighbor. And we also want to help humans learn to live and work in space.
Barbara, thank you for that great brief. We're all very excited about what you can do to help our new providers support them on their access to the moon. Help us understand, ultimately we know we have amazing images. Of course, you guys have mapped the moon in ways that we couldn't have imagined before the Lunar Reconnaissance Orbiter, and we know that we can get images after they land. Are there things that you can do while they're in the process of landing on the moon to help them be better as they land in real time?
There may be. It depends on the landing date and our viewing geometry. So LRO isn't everywhere around the moon all the time, but we are working with some upcoming missions to try to pick landing dates that have favorable viewing geometries. We want to observe the plumes as the landers land and kick up dust and disturb the environment. So there are definitely coordinated activities that we want to pursue.
Appreciate you very much, Barbara. Thank you for the great brief. We look forward to working with our commercial partners and, of course, the Lunar Reconnaissance Orbiter to make sure they have everything they need to be successful. And we thank you for all of your support and all the support from the Goddard Space Flight Center. So thank you so much. And yes, please. Now, as I mentioned, we have a group of first LEGO League teams from the DC area here with us today. This year's first LEGO League challenge is called Into Orbit and is centered around exploring and innovating in space just like these companies are going to be doing in the very near future. One of those teams, the Cascades Thunderbolts, is going to show us that challenge right now. Let's go to NASA's longtime champion for FIRST Robotics, Dave Lavery.
Thank you. Many of the companies that we're partnering with today were founded and created because years ago, when their founders were students, they became inspired by space exploration. Today, we're working with FIRST to help inspire the next generation of students and have them follow through on the same dream so that this will become the future workforce who will help develop and create the next generation of missions that will follow the commercial activities that we've been announcing today. With me today, I've got the first LEGO League team, Cascades Thunderbots, and Disha is here to help me explain what they're going to be doing. This program is designed to help students understand advanced technologies, get initial entry into coding and programming technologies, as well as explore certain research topics. This year, the theme is all about space exploration. And Disha, why don't you tell us what's going on?
Sure. So this is our robot. And the first mission that it's doing here is called space travel. So basically what it's doing is it's going to attempt to drop 3 different compartments onto the space travel ramp. But it looks like it went a little bit too far to do that. But it got 2 of them. And then while it's doing that, it's also going to push the solar panel array. And then now they're going to be setting up for the next mission, which is called satellite orbits. And in this mission, the robot is going to try and drop 3 different satellites in between the outer orbit lines. And one of the satellites is actually on the mat, so it has to bring that one back towards the outer orbit lines. So here right now it's traveling towards the destination. Oh, it crashed.
Sometimes space is hard.
But now they're going to be doing the last mission, which is called Escape Velocity. And in this mission, the robot needs to impact the strike pad hard enough so that the rocket flies all the way up to the top of the structure and stays there. And this sort of represents how much energy it actually needs to launch a rocket and have it pull away from gravity. And then while it's doing that, it's also going to be doing this mission called the Observatory. So here it's doing both at the same time. And
there we go. That's our first launch as part of the new commercial lunar payload system. Mr. Administrator, back to you.
Well, that's fantastic. The Cascades Thunderbolts, everybody. So one of NASA's missions is to inspire the next generation. And of course, when we land things on the surface of Mars, as we did just on Monday, you think about how many people in the world saw that. Raise your hand if you're in this room and you saw that as it was happening. It's really amazing. It was on the cover of, did I hear a clap down here? All right. It was on the cover of over 200 newspapers worldwide, and that's just what we've been able to gather. It's probably a lot more than that. And that's how we inspire the next generation. And things like the Lego League, the First Robotics Lego League is another opportunity for us to get that next generation involved. And we're so excited about them eventually stepping up and taking the place of these companies that are taking us to the moon here in the near future. Now we're going to check in with our Johnson Space Center in Houston, Texas. Astronaut Stan Love is going to show us a simulation of moon gravity, and scientist Andrea Mossy is going to discuss lunar samples brought back during the Apollo era.
Hi, I'm astronaut Stan Love here at Johnson Space Center. In 2008, I flew on the Space Shuttle Atlantis on mission STS-122. Today, I'm in the Argos, or Active Response Gravity Offloading System, which is taking 5/6 of the weight off of my feet and putting it into this harness, allowing me to simulate what it's like under lunar gravity. We'll use facilities like this one when it's time for us to start preparing how to learn to walk again and then how to work on the surface of the moon. And joining me here is...
Hi, I'm Andrea Mosley, Apollo Sample Laboratory Manager and Principal Sample Processor. I've worked with the moon rocks for 43 years, and I love it.
Well, my office mates and I would love to bring you some more lunar samples, but we understand you already have some. What will you do with the new ones?
We only have a limited amount of samples, and we have sample processors. We have principal investigators at Johnson Space Center and all over the world who are actively waiting for the return of more samples to do research and sample analysis.
Excellent. So while all the astronauts would be ready to launch to the moon tomorrow if they had the chance, we understand we have some smaller steps to take first. The Commercial Lunar Payload Services is one of those. We'll be partnering with American industry to put machines back on the surface of the moon. They will do some exploring, analyze what they find, and maybe bring us back some more samples. That's the first step. Then we understand that after that, we will be able to prepare, get ready with our corporate partners, the internationals, and put human boots on the surface of the moon again, after which we'll ask them to dial this up to 3/8 G for Mars. Back to you, Administrator Bridenstine.
Thank you. Thank you so much, Stan and Andrea, for your great work, and we can't wait to see what's in the future for both of you, as well as for what we're able to accomplish as an agency. We got Dr. Zurbuchen back on stage here, and now we're going to just open it up to the audience, open it up to the online audience, and answer questions that you may have. And I'd like to start by going to the FIRST robotics students that are here. If there are anybody among the FIRST robotics that might have a question. That's great. We'll start right here. This young man right here in the blue shirt in the front. Oh, actually, I guess it's already been determined for me. We're going to start right here. Yes, sir. Can you tell us your name first?
I'm Gabe Aparicio, and I'm from the FLL Team 103.
Awesome.
And our question is, we learned that you can use 3D printers to create parts that may not exist. This is called fabrication. Can the astronauts do their own 3D printing on the moon if you deliver the raw materials to them? Thank you for taking our question.
The answer is absolutely. And not only do we need to deliver the raw materials for them, we'd like them to take a 3D printer to the moon and actually use the materials of the moon to develop what they need to survive on the surface of the moon. So the idea, we call that in situ resource utilization, utilizing the resources of the moon for exploration, discovery, and science. Dr. Z?
I'm actually really interested. And, you know, of these companies here, who uses 3D printing now? There's some, see? Even the majority of the companies. You see, so the printing that you're asking, that printing question you're asking, is a question that is really starting to move the industry. So by the time you're a scientist or an engineer, this is going to be common practice pretty much anywhere we go. There's even rockets right now that are being, parts of rockets that are being designed in 3D printed. And how cool would it be if we could take rocks from the moon and turn it into a 3D print that actually can build houses, can build, you know, machines that we could use up there? I love the question. It's already happening, man. I love the hat, by the way, too. Can he wear it for a minute?
That would be a very bad idea. All right, there's got to be another question from First Robotics.
So my name is Neha, and I'm from the Cascade Thunderbots. And so my question is, if astronauts are headed towards long-term space missions, and then there's clearly going to be radiation, if all the materials are already sent towards the moon, how are you going to protect the astronauts from all the radiation?
It's a wonderful question. There's a number of ways to do it. The radiation can be mitigated by just having it impact material before it gets through and hits the astronauts. That's a big challenge, though, because you have to have a lot of material to interact with that radiation to protect the astronauts, and that's very heavy. And when you think about things that are heavy, it makes it very expensive to get those things into space. So it presents a big challenge. One of the ways we can mitigate the effect of radiation on a trip to Mars, for example, the way to mitigate it is to get there faster. So there will still be exposure, but if we can get there faster, maybe 2 or 3 months instead of 7 to 9 months, it limits the amount of exposure. So in order to do that, we have to have advanced propulsion capabilities. We're talking about things like maybe even nuclear electric propulsion or nuclear propulsion in general. So these are things that we need to be able to develop so that we can get there faster to protect the humans on their way to Mars. Once you get to Mars, or even on the surface of the moon, where there's a lot of radiation on the surface of the moon, there are ways that we can, once there, protect our astronauts. The way to do it is to go underground, or build a habitat and put lunar regolith, or parts of the surface of Mars, on top of those habitats to create as much protection for the astronauts once they're on the surface of another world, as much protection as we can. So it is a big challenge. NASA's working on it, and we've got to figure it out because ultimately we want to go to Mars, and when we get there, because Mars it's in an orbit all its own, it's not like the moon. The moon and the Earth, we're always together. Wherever we are around the sun, we're together. Well, Earth and Mars, sometimes we're on opposite sides of the sun. So when our astronauts get to Mars, they're going to be there for a period of years before they can come home, which means they have to be protected from the radiation environment. So it's a wonderful question. Know that NASA is working on it, and eventually we're going to come to a good solution that's going to enable our astronauts to go there safely.
You know, I would guess that in the first 4 landings on the surface of the moon, there will be at least one instrument that is just like what you said, focused on radiation, because we care about it so much. We care about it so much that, do you remember that spacecraft they talked about, the Lunar Reconnaissance Orbiter? Even on that spacecraft is an experiment that is focused on radiation and measures right now how it's working. So everything the administrator said, of course, is entirely correct.
Of course.
But the thing is, we're doing it's all about science that really opens the path for human exploration for us to know what to do. And we're learning that right now, and we'll learn it through these services.
Awesome. All right, we're going to go to the audience here. Questions from the audience?
Can we go back to the 2 kids here?
Yeah, we want to start with the children? Yeah, that'd be great.
Yeah.
Not your children, young adults.
He has his hands up since the beginning, so I'm like.
My question is, if you wanted to take humans to Mars, I think there would be 3 ways to do that. Using solar energy, battery power, and gasoline. If you use gasoline, that would be the source for when everything runs out. And if you use battery power, that would be for the source when the solar energy goes out.
Yeah.
And to protect yourself from radiation, I saw that they thought of a solution.
Yeah,
so you should put
you're exactly right.
foam inside of the suits and water.
We're with you 100%. So right now, NASA is developing those kind of capabilities. In fact, we're developing right now what's called Gateway, which is going to be in orbit around the moon. Think of a reusable command module or a small space station in orbit around the moon. And that particular spacecraft is going to have solar electric propulsion that's going to enable it to maneuver all around the moon. And it might come to a day where our providers that are going to the surface of the moon could use the Gateway as either a stopping point on the way to the moon or a stopping point on the way home from the moon. So these are all great capabilities we have to develop for the future. So thank you for the question. Other questions?
Keith Cowling, NASAWatch.com. I don't want to be Debbie Downer, but I have a question. I'm looking at your fancy Moon to Mars logo, and 15 years ago, almost to the date, I sat right over there when President Bush had the different arrangement of words and said, we're going to go back to the moon in about 10 years. 15 years later, we're still 10 years away or so from humans. Your Mars charts stop with Mars sample return. Your Moon charts stop with a single human landing. There's no from there to here bridge chart. And I'm kind of wondering what NASA's been doing in the ensuing 15 years. I mean, I know the answer, but I want to hear yours.
Yeah.
I mean, the only thing that seems to have changed is the color of the carpet in this room.
Negative. Negative. That's not the only thing that's changed. If you look at Space Policy Directive-1 from the President, he says we're going to the moon, but we're doing it in a way we've never done before. So what that enables us to do, according to the Space Policy Directive, to partner with commercial industry. In other words, going back to kind of my original statement, NASA becomes one customer of many customers, which spreads the cost, and it actually reduces our risk. It spreads the risk as well. So our cost and our risk is lower than it otherwise would be. And we have multiple providers that are competing on cost and innovation. This has never been done before for a trip to the moon. And when we think about the way we're going to the International Space Station right now, we've already proven it with commercial crew, or I should say with commercial resupply, and pretty soon with commercial crew. So we're taking what we've learned from our experience with the International Space Station to drive down cost and increase access, and we're applying it to cislunar space, and it starts with the Science Mission Directorate. So to answer your question, Keith, and I think this is important because I get this question a lot, this is not going to be Lucy and the football again. We're not planning to go to the moon, and then we're going to not go to the moon. The reason this is more resilient than before is because we have commercial partners that have customers that are not necessarily NASA, and NASA can be a customer. And we have international partners on a level that we've never seen before on the planet. More partners than ever before, and their level of excitement is as high as it's ever been. Everybody is ready to go back to the moon, and that is ultimately going to build resilience into the system so that this time when we go, we're no kidding going to go. Thank you for the question.
Jeff Faust of Space News. I'm going to interrupt all the really fun stuff with some boring but important details. Exactly what are the companies getting with these contracts in terms of upfront money? How is the process going to be for matching up payloads to rides when that comes? You know, just some more of the details about exactly what is being awarded and the reason why we're here today. Thanks.
So what the companies are through that is they're becoming part of the catalog, so to say. And as part of that, they will compete for tasks that we're going to put out there in weeks and months from now. So we're not going to sit on our hands on this and start to put tasks out. The companies then can propose to complete these tasks, and we want to move forward on that. So what they're getting is that. How they're going to bid that exactly is entirely up to them. They're also going to choose how they get to the moon. For example, what launch vehicle they're going to choose as part of the service that they're doing. So what there are as part of that is really a set of options that we're going to exercise. I just want to say, Jeff, and of course you know that this catalog will change over time. We actually expect that we'll create other on-ramps. We already told that there's companies that may be invented right now or some that will also want to be part of that. History also shows that as we go forward on doing such difficult things that sometimes companies merge, sometimes other things happen, but the catalog will change. This is an entrepreneurial activity. And we want to be first customers, not only customers. We want to be first customers with a broad set of other customers that are out there, both nationally and internationally. So that's what they're getting.
We have a question that's coming in on the phone line from Leonard David, National Geographic. Can you hear us?
Does NASA have its act together right now on the types of experiments that you want to send to the moon to begin with? And the other thing that has miffed the lunar community is that you canceled a lunar mission to look for ice. And is it conceivable that could be reinstated in the future? Thank you.
So first of all, this is Thomas Serbo, and you don't see me, the guy with the accent. First of all, we already have experiments that are out there and that were developed by the Planetary Division. David Scher did a lot of the work together with the procurement team. Just want to shout out to them. Just thank you for all the hard work to get this together, signing these contracts and everything. So we have some of the experiments already. We actually looked within the agency already what's out there that we could build. We have a set of instruments that are ready or almost ready to go on a timescale that we believe our delivery service will take to get their vehicles together and on rockets. So we have some that one of them is actually a really simple one. It's a retroreflector. We actually are not only flying that on each and every one of those landers, but also the international landers that are going out there. We've signed partnership agreements. You and I were in Germany, where we signed a partnership agreement with Israel, and I saw a picture today. It's mounted on top of that lander. See, together with many of these retroreflectors, we can do unique things about the science of the moon and also the infrastructure relative to timekeeping and otherwise that comes from being able to communicate with lasers back and forth. So yes, we have some instruments. Some of them are actually the very instruments that you refer to, resource-focused instruments, whether they're ones that look below the surface in gamma rays or neutrons, or look at samples off the surface like mass specs and so forth. We have, as you know, of course, we've continued to support those instruments, both together between human exploration and science. And you're also aware of the fact, of course, that rover of the type, a mobile platform of the type that was similar to the one that you mentioned, is actually part of our plan. And in no way have we stopped working on this. Quite the opposite. We put a lot of energy in it. Actually, Steve Clark, who is our deputy for exploration and science, is making it a key focus, his personal focus, to really drive that forward together with the various parts of the agency and providers that are out there. So yes, we have instruments, and yes, we're going to pull that rover forward and going to land on the surface of the moon in a few years.
And I think one of the important things to recognize is with 9 different companies all capable of getting to the moon, in fact, we can get to more parts of the moon than we've ever been able to get to before to test different regions of the moon. You know, a lot of people don't realize from 1969 up until 2008, a lot of scientists, they don't recognize it now, but a lot of scientists at the time believed the moon was bone dry. Of course, now they tell you, oh, they knew all along there was water ice on the surface of the moon. But a lot of people really believed the moon was bone dry. 2008, India made a discovery. 2009, NASA doubles down on that discovery. Now we believe there's hundreds of billions of tons of water ice on the surface of the moon. And we're going to be able to explore more parts of the moon than ever before because we have multiple providers. We're not just sending one rover to one spot on the surface of the moon. I understand we've got a phone call question from Rebecca Boyle of Air and Space Magazine.
Hi, thanks. I hope you guys can hear me. I have kind of weird audio here.
Loud and clear, Rebecca.
Okay, great. Thanks for taking my call or question. I guess I'm hoping you can both talk about sort of the pace for this program and why it's a little bit slower growing maybe than what we might have learned from Apollo. The smaller commercial rovers early on, mid-sized landers later, and several years from now, crew-carrying landers. I guess what's the benefit of doing it on that sort of slower evolution time pace, and what do you hope to learn from that process as opposed to setting more ambitious deadlines?
So it's actually interesting. I would have actually said that the timeline that we're putting in front of us to get to the surface of the moon is unprecedented. We've never done anything that fast. It's that simple. And so for me, in all of history, by the way, I think the only thing that rivals it is Explorer 1, where as a reaction after Sputnik, kind of historically, we put payload out in low Earth orbit to the surface of the moon. This is the fastest. The reason we're doing it so fast is because we think it to be an important part of a multi-level strategy, a strategy that has on the one side speed and really the growth of an industrial sector that is in the US and allows us to really create strength and grow that market, take some ambiguity out of the system by being customers, one of many. On the other hand, we have other things that take a while. For example, when there's payloads with pulse, humans that are going there, we want to take the appropriate time so they're absolutely safe. Will every one of those landers that we're talking about be 100% successful? I doubt it. What we're doing is really hard. We're going at high speed.
No offense.
We're perfectly fine. Kind of history has shown that it will take us sometimes 2 attempts to be 100% successful. But we're also not starting from scratch. There's a lot known in the entire kind of industrial kind of community and within NASA and on the outside, and some of it has already been transmitted through programs that we had in the past. So it is fast, the front end, but it's a multi-segment strategy, and some of them, of course, are necessarily slower than the absolute fastest front end that we're talking about today.
That's right. The way I think about it, think of it like venture capital. Our investment is low because we have other people that are investing. In other words, private sector, they're going to have customers that are not NASA. Our investment is low. The risk is higher than it would otherwise be. But we have more providers. In other words, the portfolio is larger, so we can take risk. And the way I like to talk about it, the way I've heard you talk about it, we're taking shots on goal here. We're trying to get it done fast. We're trying to very quickly develop an American capability to deliver small payloads to the surface of the moon and then grow from there. And we want medium-class landers. We want large-class landers. And, of course, we're going to have human-class landers within a decade. All of that being said, we also want to get there fast. So when the human-class landers are there, they have the opportunity to maximize every moment of time that they have when they're there. So it's a fantastic question, and we appreciate it very much. We're going to go to social media now. I understand there's a lot of social media questions that are coming in, and I don't know where to get those.
Yes, sir. This is from Twitter user Spike Page.
Okay.
Does NASA see itself becoming a part of an international lunar habitat similar to the ISS in the coming decade?
So you're talking about a lunar habitat similar to the ISS in the coming decade. That was the question. I think that it is possible that we can have a presence on the moon with humans, not permanently at that point humans, but within a decade we will have humans on the moon intermittently along with landers and rovers and robots. So at the end of the decade, a decade from now I would say, we can have a continuous presence on the surface of the moon, but not necessarily humans the entire time. And I think from there we build. And the idea would be, of course, I mean, we want eventually to have an open architecture capability to go from Earth to the moon over and over again. When I say open architecture, I'm talking about the way we do data, the way we do communications, the way we do docking, the way we do avionics. All of it would be available to the public on the internet. So any commercial industry, any commercial company, or any individual that wanted to go to the moon for their own purposes, they could access that architecture. That architecture would include launch. It would include tugs from low Earth orbit to lunar orbit. It would include that reusable command module in orbit around the moon. We call it Gateway. And it would include landers that go back and forth to the surface of the moon. So if there is a brilliant person out there who has an idea that they want to do something on the surface of the moon, and they can go attract capital and get investors, they're going to have full access to this open architecture. And when it's open, it's not just open to commercial partners, it's also open to international partners. So when you think about the future, it is indeed international. And the United States of America wants to, of course, have a huge part of it and, in fact, lead it. That's our objective. But again, we want to do it in a way where we can do far more when we get commercial and international partners than we could ever do on our own. And that's one of the reasons, going back to Keith's question earlier about how is this not Lucy in the football again? Well, when we do it in this open architecture way, it builds sustainability, which is part of the President's first Space Policy Directive. Okay, I was told another social media question.
Sure. This is from Twitter user Miguel Best. Will the upcoming moon missions be live streamed like they were with the first man on the moon missions years ago?
Thomas?
What do you think, guys? They say yes. So, look.
So from my perspective, the answer is when we put out the task orders, of course, that's when we're going to make our requirement as far as what we want from our providers. And in my opinion, this is the truth. The more we're able to communicate what we're doing on the surface of the moon, the better it is. We want everybody to see what we're doing scientifically. We believe that in the end, when this is successful, there's going to be a level of investment that right now none of us are expecting. There's going to be a return on that investment that right now none of us are expecting. And in order to achieve that, we've got to make sure everybody sees what we're doing while we're doing it. You think back to Apollo 8. You know, Christmas Eve, December 24th, 1968, our 3 astronauts were in orbit around the moon for the first time in human history, and on Christmas Eve, taking great risk, they keyed the mic to do a broadcast to the entire world. 1 out of every 4 people on the planet in 1968 heard or saw that broadcast. 1 out of every 4 people on the planet. You think about the way communications work today compared to 1968, it's not going to be 1 out of every 4. We're going to come to a day where it's 1 out of every 1. And people are going to say, wow, look at what they're doing on the moon. It's going to be incredible. And that's the future that we want to achieve.
Now, keep in mind that one of the reasons that we're really interested in the timing of the landing not just for communication reasons, is the science that was outlined here. When we land, there's some stuff that comes up off the surface that really creates a sample that we can observe from orbit, but also from the Earth sometimes. And that's a unique opportunity. So we absolutely want to know when exactly and we go down there in every time and actually be aware of it and take all the learnings that we can, the maximum of all the learnings that we can to our benefit.
Absolutely. I've been told we have time for one more question in the room, then we're going to go to the phone for a final question. So one more question for the room. This young man, fantastic. You've been so patient. Thank you.
My name is Jaden, and so the air in space is thinner, so does your speed change in space?
Does the speed change in space, Thomas?
Tell me again, so I want to make sure I answer the right question. What changes?
So he
does
said,
your speed change because the air is thinner in space?
Oh, right. You're right. So basically, if I throw a ball, right, through the air here on Earth, right, it slows down. So if you are in space and you throw a ball without the air, without that friction, it just keeps going. And so you're right. It's a speed change because of that. So it slows down here, but it doesn't up there, just because of the fact that it's an entirely different environment. We can also change the speed because of the fact that we can boost it using propulsion, you know, like boosters behind it, just like you see in some of these star movies you've seen, right? Kind of whatever they are about astronauts out there, you know, like you can boost yourself. So you can also change it, especially going to the moon and landing. All of these changes need to occur to do it safely. And so, yes, the speed changes really matter, both for physical reasons, but also because we want them to change because of what we want to achieve. Thanks.
So I think that's a great question. And when you think about some of Thomas Zurbuchen's favorite people, you probably think about Sir Isaac Newton maybe and his laws of motion. And so the idea is, as he mentioned, when you throw a ball in the atmosphere, there's friction. The air catches that ball and it slows it down. Well, in space, there is no air. And then when we think about how do we get to orbit, because really that's what your question is, how do you get to orbit? Well, the acceleration of that ball is as fast as the acceleration of gravity towards the Earth. And so the ball is going around the Earth all the time with nothing slowing it down depending on how deep the orbit is. But at the end of the day, it can just stay in orbit for a very long period of time. And the further you get from the Earth, when you're in that orbit of the Earth, it'll be there forever and ever and ever. We've got satellites that are in what we call geostationary orbit and even beyond geostationary orbit that are going to be there for thousands and thousands of years. And that's the difference between that area of space. You say it has no air, and therefore it has no drag, and it can stay there for a very, very long period of time. And that's a good thing when you want it to be good, and it can be a really bad thing if your satellite has a problem or if it blows up, which has happened from time to time, and then you've got debris out there in space. All right, so we have one more question, I understand, from social media. Or is it from the phone? From the phone. Megan Bartels is what I'm being told. Megan Bartels on the phone from space.com.
Hi, can you hear me?
Loud and clear.
Wonderful. So I was wondering if you could talk a little bit about the criteria that were used in making this decision and what sort of materials the companies needed to provide.
So frankly, what we tried to do on this one is to go relatively broad. It makes no sense to us to go select out based on kind of some criteria that we may come up with using our own development cycles to cut down the competition. We believe what should decide on the success and the viability of each one of those partners should be how they deliver these services that we want. So we went with a really broad set of criteria that really ask questions about the overall viability as companies, their likelihood to be able to deliver these services, but we did not go in very deep depth relative to the technical capability, because frankly, that's going to come next when we're going to talk about the very actions that are, the tasks that are going to come our way. From procurement, did you want to add any comment to that?
No, sir, you did a fine job.
All right. Thank you so much.
Well, what an amazing day that we've had today. This is a great announcement. This is really the first step of moving forward in the President's first Space Policy Directive. We're going to the moon. We're going to utilize our commercial partners. We're going to utilize our international partners. We're going to retire risk. We're going to prove capability and technology. And ultimately, we want to take it all the way to Mars. We're going to utilize the resources of the moon, which is something that has never been American policy before, but it is now. And we're going to use our commercial partners in order to help us not just know where those resources are, but help us understand how do we take advantage and utilize those resources. Specifically in this case, we want to take advantage of the water ice that we believe is available in hundreds of billions of tons on the surface of the moon. So what an amazing day. I'm so proud of this agency for coming to this point so fast in trying to accomplish the President's vision for space. And I'm proud of these companies that have stepped up to the plate in rapid fashion to put together their proposals and their ideas for how we can best take advantage of the moon. So thank you all so much for being here, and can't wait to see what the future holds. Thank you so much. Good job, Thomas.
Thanks. That's good.
Thank you.